All right, welcome back to Calculus 2. We are going to be tackling Euler's method today, knowing that y of 0 is equal to 0. H is going to be 0.1. That's pretty standard from your textbook. Your dy by dx is equal to xy plus 4. And we're just going to speak, can we figure out y of 0.5? Okay, so what's our starting condition? We have x and y are both equal to 0. Okay, y of 0 is equal to 0. So that's our starting spot here. Then we're going to have g of xy. So we have xy, x times y, plus 4. Okay, and then what we're going to do is we're going to evaluate this. And we're going to end up, excuse me, with 4. 4 times zero point 0.1 is zero point 0.4. Okay, so that's what we're going to do with like after we've done with this. This gets cycled back into my next y value. Okay, so we've stepped up by 1. The next value for y is going to be zero point 0.4. Okay, because we have that right here. X, the next value for x is just going to be x plus h. Okay, so we're just going to say x is going to be zero point 0.1. Okay, 0 0.1. So g of xy. Okay, so we're on our number 2 here. Okay, so this is x is zero point 0.1. Okay, y was 0.4. Okay, this is not y of anything. This is the value for y. Plug this back in. Okay, we might want to have another little segment over here just to say 0, 1. Okay, to kind of go through and make sure that we're keeping everything straight. Okay, and again, getting enough room and dealing with this. I don't want to go off to the side too much because I don't have too much side to work with, but we'll go ahead and say, okay, xy, so that's going to be zero point 0.4, that's my y, times my x, it's going to be 0.04 plus 4. Okay, and then we're going to multiply by 0.01. So I'm going to go ahead and use my calculator because I'm going to be lazy. And we're just going to say, okay, we want 0.4 times 0.1 equals plus 4 equals, and we have 4.04. Okay, so we're going to say this is 4.04. And what we're going to do is we're going to multiply this whole thing by 0.1. Okay, so we're going to say times 0.1. We're going to get 0.404. Okay, sounds like we got to the wrong part of the internet here. Okay, so we're going to go through and say, okay, we need 0.404 all the way back over here. Okay, this is our second value. X, our new X is going to be, we're going to add 0.1 to the previous X. So that's going to be 0.2. Okay, and now we have to go through and calculate our g of xy again. So this is going to be 0.404. What was my X value is zero point 0.2. And we're just going to add 4 to this thing. Okay, so we can go ahead and do that. So we're going to say 0.404 times zero point 0.2 equals plus 4 equals, so this is 0.40808. Okay, and then we're going to, so this is 4 point, what do we have here? 0.4, there it is, 0808. Okay, and then we have to multiply it again by 0.1. Okay, so times 0.1 equals, and I got 0.40808. So 0.40808. 40808. And this is what's going to come to the next value. Okay, so we're going to come over here. We're going to say, okay. So this was 0.40808. What is my X value? Is going to be 0.3. Okay, so we'll go ahead and do that. So we're going to have 0.40808. I guess you need a sharp pencil to do this problem. Times, what's my X value? 0.3 plus 4. Let's go ahead and figure that out. So 0.40808 times 0.3, about 0.3. Okay, times 0.3 equals, add 4 to this whole thing, so plus 4. Okay, and then we're going to also multiply it by zero point 0.1. It's just going to move the decimal place, but 0.412242. Okay, we'll keep going with that. And we'll say, okay, this was 0.4, and I lost this thing because it's over here. 4, 1.224. Okay, this is my next value. Okay, I can't tell you like where's the best place to round off because you should round off at a certain point. If you don't really know, almost every time that the people do this, it's usually to 4 decimal places. So I think that's usually your safe spot to go with. Until I have to, I'll just keep keeping the number I have just to be as accurate as possible. But 4 decimal places is a reasonable place to cut off. So we're going to say, okay, this is 0.41222424. X is now 0.4. We just add 0.1 as we go up. And we're going to go ahead and say this is 0.4122424 times zero point 0.4 plus 4. Right? XY plus 4 is our value here. So we're going to have this. We're going to say times 0.4. Right? Plus 4. Okay, equals, and then we're going to multiply this by 0.1. Okay, so it's going to be 0.4164, let's see, 896. It looks like 89696. Okay, so I was going to put in this for my new y value. So 0.4164,89696. And we increase our y value, we increase our x1 more, so 0.5. Oh, what was the answer, what we were trying to get? We wanted y of 0.5. Well, here it is. We're done. Okay, so y of 0.5 was equal to okay, 416489696. Okay, and this was the answer we were supposed to get for this thing. That's all you're being asked to do. Okay, we're not asking you to do anything more. This is it. All right. So figuring out Euler's method, there we go. And that is problem number 5. Okay, so again, practice with, again, the more you do, like you'll get an idea of like how big and how do I have to make my table, realizing like the first couple, like this first column, you're gonna have to make pretty wide. The second column, or you could swap them, put the X first, and where you're gonna stop. Okay, you're gonna stop one before you think you actually need to, and then just practice getting through this and figuring out this little pieces here. So Euler's method, very useful thing to deal with. It's the first differential equation solver that there is. Let's see, I think ODE 4.5 is the MATLAB command to solve this thing. And what happens is that you try to figure out like the slope. You have a point, you go up here with the slope, and then you reevaluate to get a different slope, and you just kind of follow this around as you're going forward with this. All of the differential equation solvers use a similar method, except that what they're going to do instead is they're going to go back and they're going to say, okay, well, what was the slope halfway here? Maybe it was the slope a quarter of the way here. So they're going to average all of these slopes to get the next slope, and then they're going to do the same thing. So instead of getting this one slope, they average a bunch of them to get another slope. But that's effectively, we haven't come up with a better way to solve this. So almost all of the differential equations solvers that we have, numerical solvers, they're pretty much a refinement off of what Euler's method is. That's pretty much the best we've came up with to do this. Okay, there are other methods. There's Wade's methods. There's ODE 4.5, which averages 4 and 5 slopes together. Okay, so you can kind of figure out what's going on with that one. But the idea is always going back to Euler's method, and that's how you pronounce his name. So that's a good thing to know too. Okay, so very good with all of that. I hope that helped a lot with being able to do those. You will be provided the formulas for Euler's method, just asking you to be able to perform it, and that's what we have for that. So good luck studying for everybody. Good luck on the exam, and I will see you in the next video. All right, good luck.